All right, when I think about waves, I like to think about things that are moving. The wave pulse, that thing that we've done to excite the medium that we're traveling in, whether it's air or a slinky or whatever, that pulse travels through the medium, through the spring, through the air, whatever it is, and actually moves, and it can move forward. So when I create a wave pulse here, it travels through the medium and then ends up over here. It has a certain speed to it. So there's a variety of different types of wave. Some go faster, some go slower. Now the question is, what is the velocity of a wave and how do I actually calculate it? Well, I like to think about velocity of waves in terms of the frequency, how often, and the wavelength. So when I think about frequency, I like to think about walking. So I can take certain number of steps. If I walk frequently, that means that I'm moving my feet frequently. So I'm taking a lot of steps. So when I think about frequency, I think about the number of steps that I'm taking. Now some people run faster than others, so therefore some people take more steps. Mrs. Hessler walks really fast, so she takes really fast steps. It's very hard to keep up with her. All right, now the next thing is the wavelength itself. The wavelength I like to think of as in terms of the stride. So some people when they walk take a very long stride when they walk, and they actually cover a lot of ground for each step that they're taking. I saw on the Olympics, they were showcasing a few highlights from the summertime, and they had runners, track stars from Nigeria. These people, I tell you, they are super tall, their legs are really long, and they run really, really far. They're great at marathons. So the body style that this particular team had with people with very long legs. So when they walked, they took huge strides, which gave them a competitive advantage in long distance events. They could travel farther just because the stride themselves, they had to take fewer steps. And I think that's a competitive advantage for them. So let's suppose I want a high velocity. What I'm going to do is this. I'm going to take a lot of steps frequently. I'm going to do frequent steps, and I'm going to have a long stride. So when I come by the camera, boy, I like zoom past it. Now, suppose, for example, I lower the frequency and the size of the strides. So I'm looking here. Now I'm going much slower because the number of steps that I'm taking is less frequent and the size of the stride. So waves are like this. It's the number of steps times the length of the stride that counts.